So we are huge consumers. Each person on this planet needs a tremendous amount of these minerals in order to live the lives that we expect to live. And, these are enabling, all these technologies are enabling most of the world to live a better and better life.
This is the Game Changers Video Podcast. Stories of people, ideas, and technologies that are making the world a better and more sustainable place.
I'm Jonathan Winch.
And I'm Michael Best. Good to have you on board.
Our guests today are Wayne Douglas, who is the head of technology for FLSmidth. The company is also known as FLS. And Wouter de Groot, who is head of sustainability at the company.
They're here to tell us about how FLS is helping the mining industry to become more sustainable with new technologies and practices. It's a game-changing initiative that's having a real impact on the world.
Wayne, can we get you to give us a background on how you came to become the head of technology at the company?
Yeah, certainly. So my background actually is in extractive metallurgy. So I went to college for metallurgical engineering. So there we studied both physical metallurgy, which is really just the study of actual metals, ceramics, but there's also the part of extractive metallurgy is how do we get those? So I did that for my bachelor's degree in South Dakota in the United States, went on to graduate school, and there I was fortunate enough to actually teach some of the classes, the undergraduate classes in extractive metallurgy. So I was quite familiar with the field, looking for something that I thought maybe in my youth would be a little more exciting. So I went into composites and aerospace more as a focus in my graduate studies, but really in my heart and at the core, I really did like the extractive metallurgy. So then started with a mining company when I graduated. There really learned that tremendous opportunity to do many exciting things. So worked in the mining field itself in gold. So in gold mining, extractive metallurgy there. Then after a number of years there, decided it was time for a change. I wanted to see the supplier end of things on equipment. So that's when I came to FLSmidth. There started off in charge of really the testing center that we have. From there, then moved to head of R&D as well, and now head of technology, which covers really all of the engineering that goes into our products and processes that we can offer to the market.
That's pretty exciting, and I guess maybe you wished that you'd extracted some more gold back then when you were in the mining industry. Gold's at the highest rate it's ever been right now, isn't that right?
It sure is, yeah, well over $2,000 per ounce.
Yeah,
so
that's crazy high. Yeah.
Exactly.
Well, let me just... So you were on your way to become an astronaut, and then you switched over to mining, or?
That was the goal. I mean, I even got my pilot's license. I thought I would become a pilot, and I was really into...
I think maybe you thought you needed a pilot's license to become an astronaut. That was where,
It was a start. It was a start.
Already there, we see the gap in what's required.
Exactly. So, yeah, real passion for a lot of that.
Yeah.
Exactly. But ended up doing this instead, and maybe someday mining in space.
There you go. That's your business opportunity.
Great. Wouter, what about you? How did you get to be the head of sustainability at FLSmidth?
Yeah, that was an unusual path. So I was, once upon a time, it feels already a long time ago, I was working for General Motors in Germany. And it was in what they called the aftermarket business, replacements of parts of cars. And they were one of maybe who started very early on with, we didn't call it like that, but circular economy. Because they were looking at, hey, listen, if you have a car that has had 120,000 kilometers, how much that is in mileage, 70,000 miles on it, you need to replace your oil filter. And that oil filter by itself has a lifetime of 80,000 kilometers. Why would you put a completely new oil filter in a car that's going to run out in maybe 20, 30,000 kilometers down the line? So they started to look and say, how can we create a process where we refurbish some of the old kind of oil filters, send them back to the suppliers, give them a little bit more business, and then put in a much more cost-effective oil filter back into your car. That's a little bit how I got into sort of the whole sustainability space. Then went on to working in the beer industry. I was always told that beer and mining go very much hand in hand. There are different reasons for that, I think. But spent about over 12 years in the brewing industry, working on sustainability issues there, saving water, saving energy. Had a little stint in mining. I worked on a mine site in Mozambique. That was a mineral sands project. So not really going down into the ground, but basically getting the valuable metals and minerals out of the sands and then filter them. And then had an opportunity to join FLSmidth. And I'm originally from the Netherlands. Been in Denmark for a number of years, but I never really heard about FLSmidth. It's not entirely true. I thought they were doing engineering consultancy. And it was only when I looked really into the company and considered joining that I realized, hey, here is a company in Denmark, but also globally, that has one of the biggest opportunities to contribute to climate change. I took on the role of head of sustainability, and we have, together with the people in Wayne's team and the wider organization, developed a program that can really sort of, help to live up to that potential that the company has.
Okay, so we'll hear a bit more about that shortly.
Yeah.
All right, so for people who don't know FLSmidth, can you just give us a quick overview of what it is that you do, what role do you play in the industry, and where do you stop, where do you start? So who wants to take that one?
I can start with that one. I think it's good to clarify that, because sometimes people have misconceptions around it. We are a technology supplier to the mining industry. We don't own the mines. Mines are owned by a number of larger companies like Rio Tinto and Freeport, but we are a supplier. We are perhaps the leading supplier to the mining industry. To put it in simple terms, I sometimes refer to Siemens, for example. They are a technology provider to a number of different industries, and we do something similar, but very specific to the mining. So we are what we call a full flow sheet provider. Maybe talk a little bit later what a flow sheet is, but essentially it is for most parts of the mining process, and mining has different stages, how you get the rock out of the ground until it's basically the separated product. We provide technology in most of these different stages. So we deliver crushers, right? Crush the rocks, big mills. We use a lot of pumps. There's a lot of pumping that's happening of water around the process. And we make sure that essentially the product that we try to mine, whether it's copper or gold or something else, can be separated from the rock. So this is basically the core what we do. We help to build new mines. We call them greenfields. That's rare these days. There are not many new mines being opened. Mm-hmm. We are helping to upgrade mines. Some mines are quite old and we're bringing new technology in. And then a big part of what we're doing is servicing the existing equipment around mines. That for us is a big part of the business, but it also again helps miners to make sure that the operations continue to run. A stop for a miner costs them a lot of money, so we make sure the operations continue to run. We call it improving uptime or reducing downtime. And we're making sure also that the miners get more out of their existing equipment.
Okay.
So we're really interested to hear more about mining, but tell us about mining for people that don't know anything about your industry.
Good. I mean, it is a very exciting industry. And I mean, if you look at history, right, I think most of history has been written by mining. We refer to the Stone Age, Bronze Age, Iron Age.
Oh, yeah, that's right.
So fundamentally, really civilization has been defined by the different ways we've been able to mine and use these metals. It's allowed us to preserve food, thinking of salt, something as simple as salt mining, but that used to be very valuable. The ability, of course, to win wars, to have equipment for agriculture, et cetera, that would last better. Coal, to be able to fire pottery in order to transport things. The list goes on and on. Even to today, with you think of information technology, the nuclear age, the ability to harness the very energy locked up in minerals that we mine. So to me, it's in everything we do, everything around us.
I think I heard it once that if something is not grown, it's almost always mined, right? If you think about it, as Wayne said, you look around you, right? Okay, either it's grown. If it's not grown, it usually comes out of the ground. And I think that's something that a lot of people don't realize, right?
No, we don't think of it that way.
We need it. We cannot live without it.
So how much do we need it? Do we have any figures on that? Do you know how much each of us uses from, product of the mining industry?
Yeah, and it's a big number. I mean, we figure around, 1.4 to 1.5 million kilograms or 3 million pounds is what the average person will use in their lifetime. And that's, like Wouter said, that goes into the iron and the steel that we would use, the concrete, the gold, the silver. As we start to adopt more of these electric cars as an example, that's going to be more lithium, more rare earths, and the list just goes on and on. So we are huge consumers. Each person on this planet needs a tremendous amount of these minerals in order to live the lives that we expect to live. And these are enabling, all these technologies are enabling most of the world to live a better and better life.
So you say for each of us, and I assume in the Western civilizations,
where is that localized?
In the West, yes, those
West.
figures are for
1.5 million kilograms. And that has to be pulled out of the ground.
correct.
So is Europe as bad as the U.S. in that too? Or I shouldn't say as bad, but as high consumption?
I suspect, I haven't found exact numbers. I suspect it is a little bit lower, would be my gut feel, but I think maybe not that much.
But it's still a lot higher
still
than
a lot.
any of us would expect.
Exactly.
I mean, 3 million pounds of anything. That's huge.
So everybody needs it. And, what about how does it actually, what's the state of the mining industry now? I mean, when I think about it, I think of probably like a lot of people, you think about someone not exactly with a pickaxe and so on, but, laboring against the wall of some sort of ore of some kind. And
Dark, dreary, canary bird with them. And all that.
we often
It's not like that anymore, is
hear
it?
a lot of
No.
stories about mines collapsing or something like that, and it always seems to be very sort of worker focused. What's the reality of the mining industry today?
I mean, it's so modern. I'm just thinking, the tunnels that we drive through in our cars. I mean, that's what an underground mine can look like. It's that same technology that we trust unquestioningly every day. Example is how we would, avoid, like you said, the collapses we used to hear about in the history where it was old timbers in roughly hewn, caverns and tunnels. There's fleets of some of the most modern trucks, everything being connected via Wi-Fi. The processing technology that's actually used is very, very high-tech equipment, the latest and greatest. I mean, these mines, they'll spend $3-5 billion US to develop. So absolutely,
That's just to get it up and functioning?
Yes, just up and functioning. That's just the build cost.
For one mine?
For one mine. And that's because it's all state-of-the-art technology, from the vehicles they use, the electronic systems they use, the systems, and of course the equipment that we, as FLS, provide to them.
I think mining is one of the most tech-intensive industries you will find globally. Anything that we talk about, AI, machine learning, augmented reality, virtual reality, they all have practical applications in mining, right? The miners are using that to say, how should I design my mine? How can I run it most optimally? Because it's not just that you push one product, right, which is a rock through the mine. It constantly changes how hard that rock is, how valuable the material inside of it. We call it ore grade, right? How rich is it? And you constantly need to adjust that. You constantly need to learn people new skills. So AI is a fantastic tool. It's getting deployed now faster, right? And miners are really depending on these new technologies. So this perception of mining with a pick from the 1920s deep on the ground, I mean, that's really not even the past. It is a high-tech industry. And I think that is really fascinating to see all these technologies that are so in the forefront today in the media are actually already in place and being used by miners.
It's amazing. I, for one, would never imagine, mining being an area that would be pushing technology growth like this. It's a real surprise.
It feels a little bit like digging in the dirt, right? But from what you're describing, it's got a lot further than that.
A lot.
What is interesting around that, of course, is because mining's a great industry, is what you're saying. We all need it. We need far more than most people would think of minerals and so on from the ground. But there are also challenges associated with it. Perhaps you could tell us, what effect does mining have on the planet, for example? Because
put it in perspective for those of us that aren't familiar with it, right?
Yeah, and I think this is where you guys also are going in to try and change the game, or have been doing for some time now. So let's just start with the challenges. What's difficult about the mining industry? What impact does it have on the planet? And and then we'll look at what you guys are trying to do to change that.
Yeah, I can start with that. Mm-hmm. I mean, make no mistake, mining is a intensive industry from an environmental point of view. We are talking big machinery here, guys. Big operations. We are running these, the mining industry as such is running gigantic mills there, right? This is big rocks that needs to be crushed. That's still the nature of the business, right? This is high tech. We are constantly improving on that. But these mills that we are putting in place at our customers, they use a lot of energy, right? A lot of energy, a lot of electricity. 3% of all the electricity in the world is used by the mining industry.
That's
and
amazing.
just one part,
3%, you said?
3%. Mm-hmm. And that's just one part of the mining industry, which we call comminution, which is essentially the crushing of rock, if you want to talk about it. So that's 3% of all the electricity. So that by itself is a huge challenge, right? 1% of the freshwater withdrawal in the United States is used for mining. Right? 1%. That's a lot from one single industry. Yeah. Right? There are associations related to CO2 emissions, of course, sometimes pollution as well. So there are some fundamental challenges in the mining industry. And you were asking if we're going to dig deeper. We're not necessarily digging deeper, but what we're seeing is that some of the high-grade deposits, so where you have a small piece of rock and you say how much gold, how much copper is in that, right? The grades are declining. So we have basically mined a lot of the very rich deposits, and now we need to look at other deposits where the quantity of the valuable material in the rock is less. So you need more. You need more of the rock, more crushing, you need more electricity, more water. And since we need to increase basically how much mining we need to do, right? There is a double catch or a double whammy if you want. We need more of it, we need it faster, but we also need to mine more of it to get essentially the same amount of quantity out. And that by itself presents, I think, the sustainability challenge that mining is facing. And that requires solutions, and it requires them fast.
So it's a little bit like the oil and gas industry, which is also requiring, this smaller oil fields requiring more effort to get to the same amount of oil and more machinery and resources.
When you talk about needing to crush more and more rock, where does it go afterwards? Maybe that's overly simplified question, but what happens to a lot of this excess material?
You want to talk a little bit about tailings? It's your favorite topic.
So we call it
tailing.
Maybe also about the process here. What is it? You're crushing rock, so...
Yeah, let me I'll briefly then talk about the process. So we'll use copper as an example. I mean, if you have copper, so to Wouter's point, grades have been declining. So in U.S. history, just back to our history of civilization, copper used to be found, especially on the shores of some of the Great Lakes in the central U.S., in its native form. So you could find pure copper metal, and then people were able to work that into jewelry, tools, whatever. Well, today, that's not how you find it. And like Wouter mentioned earlier, grades, we call them, the percent of copper keeps getting lower and lower. So today, we typically mine maybe around 0.25% if it's copper. So 0.25% of the rock, the ore, has copper in it. Now, to get that out is tricky, because it's a very small amount. We need to put all the energy into crushing those large rocks. Really, they start off size of, small cars, for like the van we're in. We bring those down, and we need to get them as fine or finer than beach sand. Now, that only one particle, essentially, out of every, 400 is going to have the copper, 0.25%. So 1 out of every 400. So I like to think of salt and pepper. If you think of salt as all the ore that we have, and we have a few grains of this pepper that's our copper. So what we do is we mix that in with water. We add a bunch of air, so you get this bubbling effect, like you're sitting in the jacuzzi. So we add a chemical that really only attaches to the copper particle, makes it what's called hydrophobic. It doesn't like water. So when it sees the bubble pass it, that particle now, the copper particle that's hydrophobic, goes right to the bubble. And of course, what does a bubble do? Goes to the top. So now we've recovered that part in this frothy, bubbly mixture, like if you're doing laundry, the dishes, right? All the dirt and everything comes to the top, attaches to those bubbles. We skim that off, and now we have our copper-bearing mineral. So we've left everything behind. And that really gets to our issue of tailings. So most of it, 99 point whatever percent, is waste once we recovered our copper. We need to dispose of that. So that typically goes what you've heard of, maybe a tailings dam or a tailings storage facility are two common things. They get a lot of attention when they fail, because you can imagine all of these millions and millions of tons of rejected material are put in a huge pond. They're allowed to settle out as much as possible. They make, big dams and everything to hold it back. The water off the top we're able to bring back and reuse. But you're constantly adding and adding more and more material, expanding over, 30, 40 years. A lot of these mine lives are, at least. So that is where the waste is. Being held back, all deposited in one area. And, sometimes we can reprocess them, but in general, that's what we're doing with tailings.
So they're intended to stay there, then? They don't ever go back into a mine that's now finished being used?
Well, they can be, and that gets really to the advances. So we have new technologies. We can filter it out, so we press all the water out. That allows us then to maybe put it back in an area because it's dry. We have things we can mix very small amounts of cement with it. In low quantities, it's called paste. So then we form an actual mixture that has some rigidity. So once you're done mining, say underground, it's called paste backfill. So you backfill when you're done with this material, use that voids underground to fill it back up with a stable mixture that has those tailings in it with a little bit of cement. So there's a lot of creative ways we're doing because we want to minimize our impact with these tailings to the greatest extent possible.
Okay.
Fascinating.
Yeah, you can ask questions about it, guys, because we're going to be here for 5 hours. It's our passion topic, and
Yeah, I can hear that. Yeah.
we need a separate podcast on that one.
Yeah, we can mine that topic to quite a depth. All right. So you mentioned water right there. From memory, the mining industry, I was saying the mining industry also requires water to mine perhaps, but the mining industry uses a lot of water. What's the impact of that on the environment? What about water stressed areas and so on? What are we looking at there? And what can be done to address that problem?
I mean, I don't remember which James Bond movie it was. It's one of the recent ones with Daniel Craig, and it's all about sort of water as the next currency. I think water is gonna be a huge influence globally on society. The access to water, we've seen that already, right? We're seeing climate change driving essentially the challenge of water. I was once told that water is the face of climate change, right? That's where we actually see and feel it. And of course, mining is sort of in the eye of the storm there. It uses, as you say, a lot of water. It uses water in the process, and then you need to do something basically with the discharge. So having access to water, right, is one thing. Making sure that you use it effectively is another one. And then the third thing is how you then dispose the water once you've treated it, or reuse it again in the process. So for miners going forward, having access to water is probably one of the most important things. And that again presents a little bit the challenge that the miners facing, saying how do you demonstrate that you can use that quantity, that currency, right, that is in high demand, right, in a responsible and a sustainable way. And you need technologies for that, right? Say, can I use that water that I've used once for another time, bring it back into the process of the plant? And again, miners are very focused on quality, right? It needs to be a really clean stream of materials that goes through. Because every time you reuse something, right, there might be additional foreign particles, chemicals that goes into the process. So it's important that miners play a really responsible role there, right? That they understand that water, and I think miners do, that water is going to be key to their license to operate.
The water that they're using, does it need to be drinkable, potable water, or can you use a lower grade of water?
It's a very interesting point because you can use a lower grade. But here's an example. Like Wouter said, the amount of water we use and people being very cognizant of the stress that can place. But most of our I'll use copper again as an example, a lot of those mines are located, in the far reaches of the Atacama Desert. So one of the most arid places on the earth. And to your point about then, so what are they doing about water? Well, they even use seawater. So raw seawater flotation, that process that I described, some mines are using that, pumping it from the ocean way up into the mountains in order to actually process with that. Or they have their own desalination plants. So desalination plants near the ocean, once again, if they can't use the seawater, then taking as much salt as necessary out, pumping that water again so that they can get it in order to mine.
I imagine there's also some sort of spectrum, if you like, the high-tech, sustainability-enabled mines at one end, and then sort of artisan, old-world mines at the other. And that I'm assuming you guys are working with the more visionary mines. So a lot of what you're describing here sort of applies, like desalination plants, sort of applies to those who perhaps have an interest in creating high-tech, more sustainable mines. Would that reflect the reality that you see?
Yeah, just from my perspective, and Wouter can chime in, but that's really all of our equipment is designed for that miner. We're a premium equipment supplier. The size of our equipment, the requirements it would not fit with the artisanal miner. That is back to people usually in poorer countries where there's no regulations, out there just trying to survive. We've seen movies like the Blood Diamond and different ones that really show that, but none of our equipment would apply for that industry.
I'm actually really curious to hear what FLS is able to do within the industry. How are you actually changing the game? Because you don't have miners underground working. That's not what you're doing. Describe for us how you're actually doing something for this industry to change the game.
I think if I would try to articulate what we see as our responsibility is, and to put it in very simple terms, is to demonstrate that it is possible. It means mining can be done sustainably, with responsible use of water, with limited to no emissions, right? To make sure that things are being disposed in a responsible way. And we do that by presenting a vision, a technology vision of what essentially is already feasible with the knowledge that we have today and with the tasks that we have in mind, where mining needs to go to be done responsible, to make sure that we can continue mining, right? And meet the global energy and climate crisis.
So you're kind of carrying a flag for the world to see mining can be this.
Essentially, that's it, right? We've developed a program, what we call Mission Zero. It's basically a little bit based on what NASA did in the 1980s. NASA, at the end of the 1980s, had a lot of their funding being removed by the Reagan administration. They were running out of ideas, and they basically said, okay, we need a vision. We need an idea that basically brings innovation back into our organization, but basically also the entire space industry. So they created a program where they gave a challenge for their employees and their partners to say, how do we take this to the next frontier? And I like science fiction, so I like to talk about it as well. That created a series of programs called the Discovery Program. And we basically took inspiration for that. We said, where does mining needs to go? What's the next frontier of mining? How does a sustainable mine looks like? And we have tried to do that by creating a vision, which we call the Mission Zero Mine. That's essentially, how does the mine look by 2030, right? What are the key hotspots in the mining process, the flow sheet? And what are the technologies that we are working already today and tomorrow that basically address that? So we started with that roughly in 2019. And I think, Wayne, we've made some good progress since we started it out, right?
We have. So like Wouter said earlier, the vision drives decision. So we came up with that flow sheet, each area, we came up with the best possible technology. Like I mentioned with the coarse flotation, we looked at technologies that could, backfeed into better comminution, help downstream on the filtration, like Wouter was mentioning. So what we've come up with now, and the goal was by 2030. So we wanted something practical. Everything started off as a concept. Currently, I would say every technology is at what we call a technology readiness level, basically at the pilot or demo phase or already available to the market. So I would say in the next year, each of the technologies that make up that Mission Zero mine will be available. Yes, we need a greenfield if somebody's going to adopt every technology together, but the result of that mine is we feel we could have a 40 to 50% reduction in total energy consumption, as well as address the water to that 95% recovery with this new flow sheet.
So for such a big industry, that's a big reduction.
It is.
Okay.
That's a game changer.
If you show people where to go, then they start making decisions that basically leads to that path.
So you've enabled Wayne, basically.
Mm-hmm. Basically, I gave Wayne a task and he did the work.
Exactly right. So what we did is we took what Wouter had. So we had a vision, this Mission Zero, as was mentioned. We did challenge the organization, and within a year, we really said, well, we need a blank sheet of paper. And the good news is we're not going to be in this alone, because the people, our customers, they're also saying by 2030, 2040, 2050, we want to be net zero ourselves. So to do that, really, back to emissions and electricity, since we talked about that earlier, I'll use that as the example. We said the good news is, I think, the ability for the grid to become greener. So increasingly, we have a lot more solar, we have a lot more wind, nuclear and others. You see just a lot of these conversations back on the table. That's going to enable our customers to have all this energy required, because we can't reduce all of it to be able to be green. But in the meantime, how can we ease the transition? Well, it's to have equipment that drastically reduces the amount of energy required to do exactly what we were talking about earlier. Take big rocks, turn them into fine powder, be able to float out the valuable mineral, and then lower the cost of recovering that water and the energy required to do that. So we did. We said every piece of equipment starting from how the miners would move those rocks around, how do we electrify it, and how do we electrify it in a way that uses the lowest energy possible. So in the very front, okay, instead of digging underground and having diesel trucks haul the ore out, well, why don't we use our underground division, our mine shaft hoists and skips, which is basically elevators for rock, essentially. So you're able to, with electricity, move those out, avoid all those diesel emissions. The same thing goes to these huge haul trucks that are, say, in the open pit. I mean, the large ones hold 400 tons each. 400 tons each. Now, you can imagine the amount of steel
in a truck.
It's a huge truck. And think of the amount of steel in a chassis.
Oh, yeah.
You know, and say you want to also make that an electric vehicle. Okay, now you'll have the weight of the batteries. So there's this tremendous amount of weight that is being used in energy, regardless of if it has any ore in it. So we said, you know, there's much more efficient ways. We go to conveying technology. We have something even called our rail running conveyor that we've come up with too, that we're looking forward to commercialize. And that actually is a very low friction way, if you almost think of a roller coaster, but that sort of low friction, almost train wheels, able to carry the ore to the mine. Once it gets to the mine, the same exercise we did with most efficient crushers, grinding. How do we not use as much energy in flotation? Well, one of the things there is, you know, I said you have to have these particles kind of like the pepper flakes perfectly liberated, was the word we use for so it's separate. But that's because for a particle to hang on to a bubble and make it all the way to the top is a feat. So we've come up with new technology called coarse flotation, where we can be maybe that, you know, piece of pepper, the copper there has 3-4 grains of salt still attached to it. But if we can make a very gentle flotation, we can still lift that very carefully out. That reduces our need to grind as fine. So now comminution energy, which like Wouter said, that's over half the energy just used in that process of those total 3% global emissions. And then downstream, if you think you're at the beach, you grab a bunch of pebbles, the water runs off, right? You get a little bit finer and finer sand. The step finer you go, it's tougher and tougher to squeeze the water out until you're left with mud or clay. You can imagine you really can't. So our goal is to keep the size fraction as coarse as possible, the largest size as possible, still recover the metal of interest, but that makes it easier on the comminution upstream, and then downstream for tailings, a lot easier to get the water out. So that's the approach we've taken with each technology that is used for, say, recovering copper, as an example.
We can probably all agree that there's a lot of negative news out there about where the world is going.
We need more uplifting stories that can ignite hope and accelerate the changes toward the brighter future that we all want.
I want it. You want it?
I want it.
Our listeners are the people that are really curious about all kinds of things. They want to know about all kinds of new ideas and technologies that are going to change the world.
So if your company has a game changer, get a hold of us. We would love to hear from you.
So, Wouter, can you tell us a bit about the technologies that FLS is putting into place to really change the game in mining?
Yeah, I think we have a number of exciting technologies, and we have also launched a number of exciting technologies in the last couple of years. And I'm quite proud of that. I think we're walking the talk based on the vision that we set out. One of my favorite ones is our automated filtration press. That's part of the filtration process where we, again, separating the ore body from the valuable material. And we talked a little bit before about water and how important that is for miners, right? Miners need basically rights to use the water. It affects their license to operate. And miners are investing a lot in terms of how they can have continued access to water. We talked about desalination. Desalination is a very expensive process. And I think we have a really exciting technology which we call the automated filtration press, which essentially allows the miners to recirculate and therefore reuse 95% of the water that they consume. So basically you can close essentially your water loop in your mine.
95% of the water.
95%.
That's pretty impressive.
Well, how does that compare to what they might be doing now? I mean, what is it, like none, or where are we at?
I don't know if we have
Probably
more than that one.
around 30%. I mean, often if we look at our thickeners, so a thickener basically is a large settling tank that allows you to get most of the water out. And typically we call it the density at the bottom. We have a lot of really good thickener products. Then we can get that 68, 70% density, which means 30% is just water. So we are probably recovering 70% of the water as is. But you can tell that's still a tremendous jump to what Wouter was talking about with using our filters to get the rest out.
95%. Okay, so that sounds like a really worthwhile thing to do. What other examples of what FLSmidth can provide?
You know, I guess on the energy side, since we just talked about water, we have this process of, crushing and grinding we mentioned that's a huge energy consumer, half of the total energy used there. So we've come out with it's high pressure grinding roll, HPGR. So I'll use HPGR for short. We're the world's leader in mining in HPGRs. That already in many cases was taking a 20% reduction, allowing a 20% reduction in the energy required. Well, we just came out with an HPGR Pro that we've recently launched and getting very good adoption. The beauty of this product is it can be retrofit into the existing mines. To your point about it can be difficult sometimes with having new greenfield operations to put the best technology in, or we can sell it new into a greenfield. And Wouter and I always talk about there's really three areas we need to offer because we need to support the miners that have been there as well as the brand new operations. We have incremental improvements we offer on every product to service it throughout its life. We have the evolutionary, so the next generation like this HPGR that's really a nice step forward. And then, of course, some of the technologies I mentioned, like coarse flotation, others, those are the revolutionary. So incremental, evolutionary, revolutionary is what we're trying to do so that regardless of the mine, regardless of the age, there is something we can come in and do, be it an old mine or a new, in order to make it a world-class operation from an efficiency standpoint.
Wow, that's pretty nice to hear that you can, I guess, continue the viability of an existing structure that's been put in place and a business that's been built. So a lot of places in the world, I would imagine, could really benefit from.
And they do. That's a large part of our business. And I mean, like I said earlier, the investment is huge into these mines. So it only makes good business sense to continue supporting them.
Yeah.
So the burning question is, if you guys got technologies that can make mining more efficient, therefore more sustainable in many ways, what's the state of play here? It's a bit of a conservative industry. So how many mines adopt the technologies and the capabilities you offer? What stands in the way of the adoption?
Oh, we can see the wheels turning there.
Yeah, it is a good question, and it goes back to the earlier point about. I wouldn't say it's conservative by nature because, like it's been mentioned, they are very high tech. We in mining, I feel, are high tech. But when we talk about the price tag of these pieces of equipment, this is huge. Like we mentioned, it's the massive mines, huge cost to build these pieces of equipment, to install them. If the mines are already there, this isn't often just something, say your huge mill, like was mentioned, or these filters. A lot of investment already went in. So to quickly take something that may have risk when it was hard to even get the permit of the existing equipment you have, the massive investment these miners have made, and then you have a new piece of equipment that may not be fully proven. The way I think and the way we like to go about it is baby steps. You really start with piloting at a small scale on the customer site, going to a demonstration where we can take a slipstream and run that side by side, really validate the technology. And then at that point, it's really just a matter of have you lowered the risk enough where we've seen the benefit and the customer says, yes, this is worth pursuing. So often it might be a smaller or a junior miner or somebody in an industry that's demanding it, even thinking of, say, lithium and others that they really want the green credentials. There seems to be a little bit more of an appetite there for a little higher risk because their product has a premium associated with, the latest technology, reducing that emissions. They get a direct benefit by doing it.
It doesn't sound like a conservative industry when he describes it like that. You framed it as conservative, but it sounds like there's a lot of what ifs and could be's and a lot of risk taking and visionary leaps of faith.
I think that's an important point because we need to be a little bit careful with that dogmatic statement that mining is conservative. I mean, they are careful. Maybe it's a better word because, as Wayne said, I mean, these are not small investments.
No, these are huge.
Yeah, and then what I think is important to understand is as well, if you're a miner, right, there's not one mine that's the same as any other mine in the world. Every mine is unique in terms of its geological setup, in terms of its ore body. So even though we like to demonstrate that we have implemented something at one mine that works very well, a miner will still say, well, but that's a different mine than my mine. So that is maybe driving that sort of carefulness, I think is a better word to use. At the same time, miners are very open to try new things. I think we're doing a lot of exciting works at the moment, as Wayne said, with some of our customers to test these new technologies, to make sure we weed out some of the child diseases early on. So when we go into full scale, we have a fantastic product that can help the miners out there. So there are ways around that, but I think people need to understand why miners are considered conservative. It's for those reasons.
Okay, and that sounds reasonable. So, listening to the way you talk about FLSmidth, it sounds like it's a very pioneering company, but at the same time, you're also very successful, right? You're a large publicly listed company. So obviously enough people are picking up these technologies to make it really, it's not sort of, it's not greenfields in itself. There's a lot of established technology. How long has FLSmidth been around in the world?
140 years now.
So it's not a startup. Yeah. No.
Sometimes we operate like one.
All right. So there are sufficient numbers of minds that are seeing the vision, buying into the vision, and then adopting the technologies. I imagine, however, like to see more and more of them do that, not only for the company but for the planet. That's certainly what this podcast is about: is game changing for people and the planet, for the benefit.
Looking
of
at the
people and
future.
Exactly.
Yeah, where's the future of mining? I mean, can we ask that now? What's the holy grail of mining? What would be just the amazing accomplishment if you could enable that?
It's an interesting one. Something interesting too, I think, is really the use of metals and minerals. Just thinking, say, today, if lithium's required for electrification and general energy storage, that's great. We can do all this for lithium. If somebody discovers a brand new battery technology tomorrow, that completely shifts what's going to be mined and the value of that. So we in the mining industry constantly have to adapt. Is what have end use technology of these metals and combination of these metals, how are they being used? So I think we're going to see this. I think one thing I wonder is, will the history books go on after the Iron Age? Will this be the Green Age, where the world came together and honestly came to a truly fully green economy when it came to sustainable minerals extraction, electricity generation? I think in the meantime, if I'm looking more reasonable time frame in the next 10 to 20, 30 years, eliminating water completely. So we call it maybe dry beneficiation. So this is something there's very little, it'd be very much at a university research level. But the ability to actually separate out those particles like I described, instead of you having to mix the water, float those out. Imagine if we could do that in some sort of dry falling stream. So no water needed except for, maybe just mitigating
that'd
dust.
be a huge change. I can hear. No bubbles.
No bubbles.
All that bubble management expertise you guys have built up wouldn't be like,
Exactly.
Right, but that's the holy grail in your industry, is to be able to do it dry.
Well, that's one. I think but that's, of course, thinking of it like we do now. But as we all know, the history of all of these metals, there's always been some point where there's a massive breakthrough. And we look for that. What is the next one? We hope we're in on one, but there could be definitely other technologies out there that in a heartbeat would discover something novel and completely change the way we extract.
What I'm hearing makes me think that you're both very proactive and very reactive as an industry. I heard you describing, you're mining what the world is demanding, and if a new type of battery is invented and needs a new mineral, it's going to change what you're doing. But at the same time, you're very proactive in terms of looking for new ways to address the two main issues. Well, it was energy consumption and water.
Yeah, we are. And the whole industry, miners alike. We all have our eyes set and constantly searching for, every startup, every idea out there. We have our own in-house, full research lab. And that goes to Wouter's earlier point about the ability to look at every different ore bodies different. And we can test every possible technology at the lab scale, look at what the challenges our miners are facing when they give us these samples, apply different technologies. If they don't work, well, that spurs us back to the drawing board to say, what could we make that would solve this problem? So it's a fascinating industry to be in. It really is.
So if you were to look into the crystal ball there and look even further into the future, what are you seeing there? Dry form obviously sounds like it's still quite a way off.
It's a wish.
And also, I guess, implementing that in actual mines would also be a long process once you figure out how to do it. But what's beyond that? What other mining practices could you imagine being something that could help efficiency or sustainability in the future?
I think sometimes the miners don't always like this wording, but circularity is an important element in the mining. And if we want to give it a different term, reuse. But we talked about these tailings deposits, essentially what's left after we have separated the valuable metal or mineral from the ore body. They end up in these huge tailing ponds. They present a risk also for the communities in which the miners operate. So we have also technologies that can basically make that process almost exclusively dry. But I'm excited to look at how we can maybe reuse some of these deposits. We call them waste streams. I don't like that because for me they're not waste. They are another sort of part of valuable materials that we need. An example that we talk a lot about is hydrogen, right? Everybody likes hydrogen. It's a very sexy kind of new energy source. But for hydrogen, you need electrolyzers. And a lot of these electrolyzers, they need iridium, which is a very rare byproduct of copper. So you find it in these waste streams. So these waste streams still have valuable materials in it. And we are quite excited to look at basically what we can do to mine these deposits again, right?
Yep.
To separate them again and see what are some of the critical minerals and metals that you can find in there. Cobalt is another example, right? If Chile would start to mine its copper deposits, it will be the second largest cobalt producer, which is used for a number of battery-related applications, electrical vehicles, in the world. So we cannot afford to leave that essentially untouched because there will be a huge demand for all these critical materials and finding ways, and we have some technology that can enable that to reprocess that again, I think is a really exciting and also necessary opportunity for the mining industry.
Okay, because I guess there you've done the crushing of the rock. So that whole piece of the process isn't there.
I got one point on that too, because like was mentioned earlier, as grades have continued to come down over the last 100 years, and probably will continue to do so, today's, what we say waste, like you said, you don't like it, but tailings, is tomorrow's ore body. Because if I look even 50, 60 years ago, what they were throwing out in those tailings dam is equal or better than today's grade that we're mining.
Wow.
So naturally, economically,
That says
it just
something.
lends itself to go back. And like Wouter was showing these great examples of, even as we've discovered need for some, other metals that have way more value, we're able to go back. The work's been done, like you mentioned. So we have the technology to help extract that. And last point too is, I think we're going to see a shift because everybody's learned, even be it the Ukraine war and energy, but the same goes for metals, is yes, we're a global economy, that's great, but our lifeblood of everything we use every day really depends on everybody playing nice, right? Which isn't always the case. So there's a need within, I think, each set of countries is really getting together and saying, what do we feel is, the critical minerals for us? So I think we're going to see more acceptance, hopefully faster permitting, and strategically deciding that we're going to do more mining in order to protect all the technologies that we've come to love.
Yeah.
So there's a piece of having to remove some of the barriers to adopting more sustainable approaches.
And I think that's to your early question as well, and to what Wayne just said. That's the other answer to that question of what's the future for mining. I think we started this discussion about how mining is still for many people something that is far from my bed. In other parts of the world, it doesn't affect me in my daily life, which is a misconception. But I think what we're seeing very rapidly now is that mining is coming to the forefront, right? And it's becoming an industry that's just as close as beer or milk or bikes for that matter, or cars, right? Something that you associate to your daily life. Because what if you cannot get that iPhone anymore because there's a constraint of supply? What if you have to wait, like me, 2 years for your electrical car to arrive? And that's going to happen unless we find ways to accelerate more mines to be opened. If we find ways to adopt the technology to do that more sustainably faster. And they go hand in hand, right? We need to demonstrate, I think, as an industry, to those that make the decisions about, accessing more concession rights, more permits for new mines, for expansion of mines. But we need to do that by demonstrating that the technology is out there. And we keep saying that. Guys, the technology is not the problem, right? we're working on that. But we need to make sure that then that's being implemented, adopted fast, that miners are supported to do that. So that I think is the other question, apart from the technology question for the mining industry, right? Changing the name of the game, right? Is core there, right? And that change is bringing mining to the forefront, understanding how important it is for us as society, highlighting that we have the technology already there and more is coming, but we need to work together along the value chain to make sure that those barriers are being removed, that miners can operate, and that we can adopt these technologies faster to meet the global challenges. That, for me, is the future of mining.
And you described the mission Zero Mine. It's like the model mine. It's the perfect mine as you see it today.
Yep.
Yeah.
And for the foreseeable future.
Yeah, for the near future. We wanted to get something tangible and
What
close.
kind of time frame do you see that right now? When you say near future, are we talking 5 years, 10 years?
Well, a lot of the technologies within it have already been sold, which is good. So we're already starting to see commercial acceptance of the pieces. My goal would be with the right customer, in 5 years, is it unreasonable to think those would be tested enough individually that we would be, a miner, a customer would be happy to say, yes, I'll take the whole lot as drawn up based on the test work we do in the ore body that's amenable to it. But I don't see it being that far off.
Fantastic.
And again, we need to go fast, right? Remember that the mining industry as a whole has pledged to be net zero by 2050. Now that might seems a little bit far away, but if they need to be net zero by 2050, the technologies to enable that needs to be ready at least 20 years earlier, because we talked about earlier how sometimes slow the adoption of new technologies is for the right reasons, but we need to make sure, that's our responsibility at FLSmidth, that we have that enabled essentially from 2030 onwards to enable the mining to be net zero by 2050.
Okay, so if I'm hearing that right, you're saying you guys are taking the responsibility of having all the technology ready by 2030 to fulfill the requirement of a net zero mine in 2050.
Absolutely. Well, Wayne is, to be honest.
Okay, you're the vision, he's the decision.
That's right.
It's a big responsibility. Whose shoulders is it going to sit on?
Yeah.
Okay, so one other aspect, we've talked a lot about, mining's impact on the planet. And there are aspects of human rights within the mining industry that can be challenged at times. What's your take on that? What is FLSmidth doing? What are you able to do in the area of human rights?
Right.
Can you just fill in our listeners on that one?
It's a good point, and let me start up by saying that there are definitely some human rights issues in the mining industry globally. Mines are located in places where what we call the institutional framework, who should take care of making sure that people are treated correctly, paid correctly, treated well at sites, at different locations, are not always that strong. Which means that the responsibility falls automatically on the miners, on us as suppliers, also on our suppliers. So we're taking that responsibility seriously. We have really, I think, intensified our efforts in the last couple of years. And we basically look at our own operations, right? And I think we have a number of policies and stands in place to take care of that. We're looking at our suppliers, right? Who do we purchase from? Do they have the right standards in place? Do they pay people correctly? All those kind of things. But we also, of course, need to work with our customers. And that's perhaps where the problem could be the biggest at some of the mine sites globally. What we do is to perform due diligence on new customers. When we engage in a collaboration with them, we need to make sure that the standards are correctly. We are continuously putting efforts in place to monitor the risks that we have where we operate. And where possible, we work very closely with our customers to make sure that issues are being addressed for the people that work at sites, but also for the communities that surround the mine. That's often where we see some of the problems as well. There can be competition between water, for example, pollution, other kind of things, as well as some of the social aspects. So we are putting a number of measures in place. We have performed what we call a salience assessment to look at where are the big risks, what are the mitigating actions that we need to put in place. And we try to also work and collaborate with relevant organizations that are quite more knowledgeable than we are in the human rights space, that can advise us what are the best actions to take, and then we will implement them together with our customers.
Okay, do you have a human rights specialist or people dedicated within FLSmidth purely to human rights?
We have a human rights working council because you basically need to lift human rights as an entire organization. A lot of people are impacting human rights in a company. Salespeople who make decisions on what to sell to which customers, people that work in our compliance department, our top management. So we have essentially created a cross-functional body, council if you want, that looks at how we govern, work with human rights. And then we have dedicated specialists that are knowledgeable in the field that can basically steer our policies and actions in the right direction. So I think what we're doing well and what has been elementary to the success of the Mission Zero program and the Mission Zero mine is collaboration. Internally with our people, right? The Mission Zero program was supposed to be designed as a stone that we drop in the pond, that create ripples in the organization, and that, as NASA did, right, bring people to the forefront and come forward with their ideas. We're doing now a little bit the same with our customers. So we have gotten, I think, very good feedback on the Mission Zero mine. Customers are interested about it. They want to collaborate with us. So we are seeing now a number of really exciting pilots globally with different customers, right? Some of the tier one, as we call the larger one, but also some of the junior players that are interesting to work with us and collaborate. And I think that's what we always say we need more of, right? We need more customers to come on board. We are very open to that. We will open the R&D centers, our books, to say, listen, we are here in what we call the technology readiness level of this technology. We would love to partner with you to test some of these new ideas in a small scale, because I think that's how we de-risk it. If we can de-risk it, we can also accelerate at the same time the adoption of new technologies. So that's kind of an invitation. We've seen strong successes with the pilots that we have done in different geographies with different customers, but we always need more. And I think we have a good way on how to do that now.
Wayne and Wouter, thanks for being on the show. It's been really nice to hear about the mining industry. I know I've learned a lot about it.
Yeah, it's been great to have you with us.
Good. Been a pleasure. Thank you guys for having us.
Yeah, thanks for having us. I think it's an important discussion, and mining is sexy, so we need to remember that.
You guys are making it sexy, yeah.
If you've got a game changer or know someone that does, go to our website at gamechangersvideopodcast.com and send us a message. Your story could be on our show. And if you enjoy the show, tell a friend and subscribe so you never miss an episode. Until then, stay curious and keep changing the game. Thanks for watching and listening to the Game Changers Video Podcast.